Okay, so here we've got a question that asks basically with relation to differential equations. You've got a tank, initially 20 kilograms of salt, dissolved in 100 liters of water. Pure water flows into the tank at a rate of 10 liters per minute. Okay, so when you're doing questions, I guess, have an idea of what's going on, right? So you've got a tank. It has 20 kilograms of salt to start with in 100 liters of water. Pure water flows into the tank at 10 liters per minute. So pure water. The solution of salt and water, which is kept uniform by stirring, flows out at the rate of 5 liters per minute. Okay. So that, I guess, if you're dumping in 10 liters per minute and flowing out of 5 liters per minute, I guess you're getting more and more solution in there overall. If X kilograms is the amount of salt in the tank, they have to find that for us. After t minutes, it can be shown that, okay, dx dt plus x over 20 plus t equals 0. Solve this differential equation to find x in terms of t. And then, okay, let's do that first. So you're told that you've got a differential equation, dx dt equals x over 20 plus t. Now we did something like this very, plus that equals 0. Now we did something like this very similarly the other day. So we can easily make dx dt equals negative x over 20 plus t. We'll get the x's on one side, which involves me, for example, moving that to the left. And we'll get the t's to one side, which involves, I guess, me moving this t there. So in other words, get them to swap places, and I'll get 1 over x dx equals negative 1 over 20 plus t dt. What that then means is I can then integrate both sides with respect to their respective variables. And well, both of them will be log. Plus c. Now, we need to actually find c. So sometimes it's easier to find c after you simplify. So we know at t equals 0, x is the amount of salt dissolved in the tank, remember? So x equals 20 kilograms. So if we sub that in, that means log of 20 equals negative log of 20 plus c. So with that in mind, that means c must equal 2 log of 20. And that means log of x minus log of 20 plus t. Log of x equals negative log of 20 plus t plus 2 log 20. We now want to sort of exponentiate all sides. So e to the log of x equals e to the negative log of 20 plus t plus 2 log 20. Remember your exponential rules. Exponential of a plus b is exponential of a times exponential of b. Now, that you want to be able to cancel. So the exponential and log, well, you got to put the negative inside the log. So that's log of 20 plus t inverse times, similarly, log of 20 squared So the e and the log can cancel. That gives you 1 over 20 plus t. And because, well, t is positive, so the absolute value of that is positive, times 400. And the left-hand side, e to the log, again, x is positive, so that's always going to work. So that's going to be x. So in other words, x equals 400 over 20 plus t. And that's that part. Okay. So there's a further part. A second tank initially has 15 kilograms of salt dissolved in 100 liters of water. A solution of 160th kilogram of salt per liter flows into the tank at a rate of 20 liters per minute. They have a second tank. It initially has 15 kilograms of salt, 100 liters of water. A solution of 1/60th kilogram of salt per liter flows in the tank at a rate of 20 liters per minute. And you're doing 20 liters per minute. The solution of salt and water, which is kept uniform, flows out of the tank at a rate of 10 liters per minute. So both of these tanks are storing more and more solution. If y is the amount of salt in the tank after t minutes, write down an expression for the concentration in kilograms per liter of the salt in the second tank at time t. Okay. So you basically need to, I guess, separate this out. So you know you start with 15 kilograms of salt. So at t equals 0, y equals 15. You know the inflow of salt occurs at, well, I guess, 20 liters per minute, okay, of which it is 1 over 60 kilogram of salt per minute, per liter. So that therefore means the inflow in terms of kilograms is 1 over 60 times 20, which is, well, 1/3 of a kilogram of salt per minute flowing in. Now outflow is 10 liters per minute. Now you don't know the amount of salt, but I guess it's got to be y divided by the amount of salt you've got in the entire tank divided by the volume of your tank. Well, the volume of your tank, I guess, is 100 liters. So basically, you need to know the solution, right? So the concentration of salt per liter. Now, the concentration of salt per liter is the total salt over the total volume. Now, the total salt is y by definition. The total volume, well, is 100 liters, how much you started with. And I guess every minute you're getting in 20 liters, but you're also losing 10 liters times t. So in other words, this is y over 100 plus 10t. All right, so if that is the concentration, then the amount of salt outflow will be 10 times y over 100 plus 10t, which is 10 times y over 10 plus t, which is y over 10 plus t. So if this is the amount of inflow per minute, and this is the amount of outflow per minute, then when they ask us to find an expression, write an expression for the concentration I guess that's that part. Y over 100 plus y over 100 plus 10t. And then I think we kind of already were starting to show the next part. Show the differential running minus t is dy dt plus y over 10 plus t equals that. So yeah, we've already got the third. We've already got the y over 10 plus t. And yeah, so what we need to basically show, therefore, is inflow equals a third, outflow equals what we already said, y over 10 plus t. So I guess the change in the concentration over time must be a result of how much you're flowing in, a third, minus how much you're going out, 7 over 10 plus t. And that means dy dt equals 1/3 minus 7 over 10 plus t. And that simply means you can then rewrite as dy dt plus 7 over 10 plus t equals a third. So verify differentiation and substitution into the left-hand side that the answer they give you satisfies the differential equation. Verify the given equation solution also. Verify the given solution also satisfies the initial condition. So basically, you're just subbing in. They've given you an answer. They just want you to verify that it satisfies. Whenever they say verify, don't bother working out the answer. I mean, we could. You can do that as practice, but you're not needed to. They just want you to verify. So let's do that. So the answer they've given us is y equals t squared plus 20t plus 900 over 6 10 plus t. And you want to verify that it satisfies the differential equation, which was dy dt plus y over 10 plus t equals a third. Well, this part's easy because, well, oh, actually, no. We will need to do a bit of work there. All right, so let's do it one by one. Dy dt means I'm going to need to derive 1/6 of t squared plus 20t plus 900 over 10 plus t, which is 1/6. All right, so it's a quotient. So I'm going to derive the numerator, 2t plus 20, times the denominator, unchanged, minus derive the denominator, which is 1, times the numerator, unchanged, all over 10 plus t all squared. So that's the derivative there. A little bit of a mess, but we've got 2t plus 20. So I guess that's 2 times 10 plus t all squared. We factor out the 2. That's 10 plus t all squared minus, well, t squared minus 20t minus 900. So actually, a lot of things will cancel out if we were to expand. But I don't really want to expand, all right? I don't really want to expand for now. So remember there's this term here. So I'm only doing the first term. The second term, we'll note that y over 10 plus t is going to be t squared plus 20t plus 900 all over 6 10 plus t divided by 10 plus t. So it's that. Yeah. So instead of doing this, right, I'm not going to expand. I'm just going to keep it like so. Okay. So now, with this in mind, let us do this a bit more efficiently. So we're subbing in now. So this is the equation we need to prove. Well, the left-hand side equals dy dt, which is this thing here. So it's 1/6 1 over 10 plus t all squared of 2 10 plus t all squared minus this whole chunk plus this whole chunk well, lo and behold, 1/6 10 plus t all squared, 1/6 10 plus t all squared, the denominator is the same. And you've got t squared plus 20t plus 900, t squared plus 20t plus 900, minus plus. Well, that just goes. You're just left with 1/6, 2 10 plus t all squared, all over 10 plus t all squared. That just goes, giving you 2 over 6, which is a third, which is right-hand side as required. So instead of expanding and doing all of that, try to see how you can sort of save yourself a bit of work. It's not really much need to expand all of that. Of course, when you still want to satisfy the initial condition. So let's quickly check. Y equals t squared plus 20t plus 900 all over 6 10 plus t. The initial condition is at t equals 0, y equals 15. So sub that in. Y of 0 equals 900 over 6 times 10, which is 900 over 60, which is 15, as required. Okay. Part E. Part E now asks, find the concentration when the tank in the salt in the second tank reaches 0.095. Give your answer in minutes, correct to 2 decimal places. Basically, the concentration, remember, is y over 10 plus t. If we go back to what we did before, the concentration we already worked out was actually y over 100 plus 10t. So you want the concentration, which is y over 100 plus 10t, to equal 0.095. So you want to find the concentration reaches that. Well, we know that y must equal t squared plus 20t plus 900 all over 6 10 plus t. We know that. So we just sub that in. So t squared plus 20t plus 900 all over, I guess, 6 10 plus t. Then you need to divide by 100 plus 10t, which is another 10 plus t, equals 0.095. So I guess we've got t squared plus 20t plus 900 equals 60 times 0.095, 10 plus t all squared. So looks like we've got a quadratic on your hands with not particularly nice numbers. Not the worst, but not particularly nice numbers. Let's multiply both sides by 10. Okay, and then expand. Move everything to one side. Minus 3300. And solve for t. So with that being t, t must equal, well, negative b plus square root of b squared minus 4ac all over 2a. Giving us an answer of 3.05 minutes. I mean, the other answer we'll just check should be rejected. Negative 23.05 minutes. Clearly that's reject. So give your answer in minutes connected to these two decimal places. This will be our answer. And that's how you do it.